Air is all around us, and as the sun warms the earth unevenly, air moves around to create wind. Wind can produce energy which is converted into electricity by using wind turbines. These turbines are like fans that generate electricity instead of consuming it. Remember the windmill? Well, it is basically the same thing, but for turbines, airlift makes the blades turn. That motion powers up a generator which triggers electric currents. A grouping of wind turbines at a single power plant is a wind farm. Categories of wind power density, the wind resources available in a location, are characterized by classes ranging from 1 to 7, with 7 being the highest. There has been great opposition to land-based wind farms, and this provoked the need for an alternative, offshore wind farms. How are they built? Turbines are anchored into the ocean by driving piles into the seabed. They are mounted and pipes are run onto the ocean floor to transport the electricity to land-based sites. Offshore wind is the answer to clean renewable energy, the answer to climate change, and the answer to air pollution. A number of different technologies are being tested. For example, floating turbines. Currently, Europe hosts most of the wind development in the world, 80% in fact. However, the United States has been making strides through policy, research, and an increase in wind power generating capacity. 2005 Energy Policy Act made the Minerals Management Service responsible for the Outer Continental Shelves Energy Project. 2009 rules and regulations were formulated for energy projects, offshore wind site testing. 2010, the approval of the Cape Wind Project indicated that the United States was serious about offshore wind. The Cape Wind Project is slated to be completed in the year 2012. The European experience of offshore wind is a good case study to analyze. There are some key conflicts that follow offshore wind, which include impact on fisheries, interference with military and aviation operations, and finally, monetary damages. The impact of offshore wind on fisheries has been discussed extensively among the public and in the scientific community. Wildlife advocates have been asking important questions, such as, are there important commercial fish areas nearby? Is the proposed site a place of habitation or breeding grounds for whales, sea turtles, and birds? Lastly, is the proposed site being developed near endangered species? Numerous research has been conducted into the effects of offshore wind on marine life. There are some obvious factors of concern. Surprisingly, it's not the actual wind turbines themselves that cause the greatest risk to marine life. It's the construction and destruction of such farms that pose the most prominent concern to wildlife advocates. The Cape Wind Project, located in Nantucket, for example, is anticipated to pose minimal risk to marine life. In fact, many proponents of offshore wind energy elicit that location is key, and protecting wildlife is the most important thing to consider when building wind turbines. There are even wildlife-friendly construction techniques available to diminish the threat posed to marine life. Furthermore, a review that was conducted on offshore wind sites in Denmark concludes that those facilities have not created any undue fatality on marine life. The interference offshore wind energy poses to military and aviation operations is a great risk. One project location in which interference with military and aviation operations has served as a huge barrier is in federal waters off the Maryland coast. The Maryland Energy Administration proposes building either a 600-megawatt offshore wind farm in relatively shallow waters or a 1,000-megawatt offshore wind farm in deeper water further out to sea. There doesn't appear to be any huge discrepancies in cost between the two proposed options. Despite the benefits of developing an offshore wind farm off the coast of Maryland, it has been determined in a study conducted by the University of Maryland Center for Integrative Environmental Research that doing so would interfere with NASA's Wallops Flight Facility in Virginia. That specific radar station is utilized not only by NASA, but also by the Federal Aviation Administration and by the United States Navy. Researchers have determined that interference with other radar stations on the Maryland coast are unlikely. However, interference with NASA's radar station in that particular location will challenge U.S. military operations on air or sea by Maryland's coastline. The flight facility uses communications, telemetry, and radar facilities to track various missions, and because of the site's location, air traffic is minimal. The monetary damages that may be incurred as a result of building an offshore wind farm can be seen in one project that has dealt heavily with this concern in particular, and that's Cape Wind. Cape Wind is probably the only project that's dealt heavily with this the United States because it's the most progressed project to date. Many critics of the Cape Wind project argue the financial commitments involved with utilizing such renewable energy. It is assumed that the cost of offshore wind-generated electricity will be costly in and of itself. Furthermore, an offshore wind farm off the coast of Nantucket may not only serve as a deterrent to tourists, but also depreciate land values. According to a study conducted by the Beacon Hill Institute published in October of 2003, many of these concerns were confirmed. An offshore wind farm is expected to cause a slight decline in tourism, which will ultimately result in job loss. Furthermore, it is also suggested that the property of homeowners would decrease by 4.6%, an estimated $1.35 billion. Solutions can be categorized simply through collaboration, revisiting techniques and sites, and finally, weighing the pros and cons of long-term costs. Possible resolutions to mediating conflicts involved with offshore wind farms may include, but is not limited to, collaboration by understanding the interests of all parties in addressing those needs before the conflicts escalate, using friendly to marine life techniques in construction or possibly reassessing the site selected, and finally, refraining from using repetitive research and pooling the findings. This means that further research funding can be redirected to the technology itself. Overall, offshore wind energy can be an asset to the United States, and successful execution of offshore wind farms in Europe confirms this notion.